Voyager 2 is a spacecraft born in an era when reaching the edge of the solar system felt almost impossible. It was designed long before modern computing, before advanced simulations, and before scientists fully understood the dangers waiting beyond the planets. Launched as a one-way messenger into the unknown, it carried with it the ambition of an entire generation. Built with 1970s technology, Voyager 2 operates on memory measured in kilobytes, with processors far weaker than even the simplest devices we use today. By modern standards, it is astonishingly primitive. And yet, despite these limitations, it continues to travel farther than almost any human-made object in history. Year after year, it has moved beyond every known boundary, venturing into regions no machine was ever expected to survive. It carries the fading but persistent signature of human engineering, moving steadily through an environment that was never meant to support life, communication, or stability. Now separated from Earth by tens of billions of kilometers, Voyager 2 exists in a realm where familiar intuition begins to break down. It has passed the giant planets, escaped the dominant influence of the Sun, and entered a domain shaped by forces far beyond our solar system. From this distant frontier, it continues to transmit data that reshapes how we understand our cosmic neighborhood. At the outer edge of the Sun's influence lies a mysterious boundary known as the heliopause. This invisible frontier marks the point where the solar wind finally yields to the pressure of interstellar space. Beyond it begins a region governed not by a single star, but by the galaxy itself. For decades, scientists believed this transition would be smooth and gradual. They imagined the Sun's influence slowly fading into a quiet, empty void. But Voyager 2 revealed something entirely different. When it crossed this boundary, the change was immediate and dramatic. Radiation levels did not slowly rise, they surged. Plasma density did not gently shift, it spiked. The magnetic field did not gradually reorient, it snapped into a new direction. This was not a slow transition stretching across millions of kilometers. It was more like stepping across an invisible line. One moment the spacecraft was inside the Sun's protective bubble. The next, it was fully exposed to interstellar space. This discovery forced scientists to rethink the structure of the heliosphere. Instead of a diffuse and blurry edge, it appears to be a sharp and well-defined boundary, more like a membrane than a mist. Inside it, cosmic radiation is partially deflected and shaped by solar activity. Outside it, conditions change suddenly, revealing a far more energetic and unpredictable environment. The implications are profound. It means our solar system is not drifting through empty space. It is enclosed within a structure that actively shields it from the galaxy. Without this protective region, radiation near Earth could be far more intense, potentially affecting satellites and even the conditions that allow life to exist. Even more fascinating is that this boundary is not fixed. Voyager 2 confirmed that the heliosphere expands and contracts in response to the Sun's activity cycle. During periods of intense solar activity, the bubble grows outward. During quieter periods, it shrinks, allowing more galactic radiation to move inward. Voyager 2 crossed during a relatively quiet phase, meaning the boundary was closer than usual. That timing gave scientists a rare opportunity to observe just how dynamic and fragile what lies beyond the heliopause is anything but empty. Instead of silence, interstellar space appears filled with structure, motion, and energy. Voyager 2 detected fluctuations in plasma and radiation that repeat in patterns, almost like weather systems on a cosmic scale. These variations suggest the galaxy is constantly shifting under the influence of distant stars, magnetic fields, and powerful events. Another unexpected discovery involved magnetic alignment. Scientists expected chaotic collisions between solar and interstellar magnetic fields. Instead, Voyager 2 found something surprising. The fields were partially aligned. This smooth alignment raises deeper questions. Is the solar system moving through a pre-shaped region of space? Or has the Sun slowly influenced its surroundings over millions of years? Either possibility suggests hidden order where randomness was once assumed. As Voyager 2 continues its journey, it is not just moving farther away. It is revealing a boundary that defines our place in the galaxy. Long after its original mission ended, it continues sending data from a region no spacecraft had ever explored before. Each signal carries information about an environment that was once purely theoretical. With every new insight, the idea of interstellar space as an empty void becomes harder to believe. Instead, what emerges is a picture of constant motion and hidden structure. Particle energies fluctuate in repeating patterns, suggesting large-scale processes shaping the interstellar medium. These are not random spikes. They appear organized, possibly influenced by shock waves from distant stellar explosions or massive magnetic structures across the galaxy. In 2019, Voyager 2 experienced a brief and mysterious communication loss. For several hours, it stopped transmitting entirely. Then, just as suddenly, it recovered. Engineers linked the event to technical issues expected from aging hardware. But surrounding data hinted at something more complex. Unusual particle spikes and electromagnetic disturbances appeared just before the blackout. Some scientists suggested the spacecraft passed through an energized plasma region. Others proposed distant shock waves or unknown interstellar boundaries. Whatever the cause, one truth became clear. This region of space is still not fully understood. Voyager 2 is not just observing a new environment. It is encountering phenomena humanity is only beginning to recognize. Attached to the spacecraft is the Golden Record, a message from Earth. It contains sounds, music, images, and greetings, created as a symbolic gesture for any intelligence that might one day find it. Today, as Voyager 2 moves through interstellar space, that message carries deeper meaning. Crossing the heliopause marked a historic moment. A human-made object leaving the Sun's domain and entering the wider galaxy. Every transmission it sends back represents something greater than engineering success. It proves that humanity can build machines capable of enduring far beyond their origin. Voyager 2 has survived radiation, extreme cold, and decades of gradual power loss. Even now, it continues operating by shutting down non-essential systems, extending its mission as long as possible. What it teaches us goes far beyond its original purpose. It is refining our understanding of cosmic radiation, magnetic fields, and how stars interact with their surroundings. These insights may shape future exploration and deepen our understanding of how life can exist in the universe. Perhaps most importantly, Voyager 2 shows that boundaries in space are real. They are not abstract ideas. They are measurable transitions that define entire environments. The heliosphere is not just a concept. It is a living shield that protects our cosmic neighborhood. Beyond it lies a region more active and complex than we ever imagined. As Voyager 2 continues its silent journey, it becomes more than a spacecraft. It becomes a witness, moving through regions no human has ever seen, sending back fragments of a story still unfolding. Long after its final signal fades, it will continue drifting among the stars, carrying with it the memory of a small world that once looked outward and wondered what lay beyond. And in that sense, Voyager 2 is not just exploring space. It is extending humanity's presence into the universe.